Now back to the build and export. Let's go ahead and create these two pipelines. Oops, I guess I need to be in the right repo. So you should be here. I'm going to create the build, and then I'm just going to go ahead and create the export pipeline. You can look at those JSONs on your own. Again, this is going to spin up the respective pods. You can see they're initializing. And it's going to build and then export the image to Docker Hub. Now, we said that we wanted a complete audit trail for, let's say I run an inference. I need to know what model was used in that inference, what training data was used to train that model, what preprocessing was used to preprocess the data that trained that model, et cetera, all the way back. So now if I'm leaving Pachyderm's version controlled data world and I'm outputting this container for inference, how can I connect that container back to what's going to run here? Any ideas? Yeah, so Docker has this idea of tagging. So normally you might tag a build with like a git commit ID or a semantic version number or something like that. Here, Pachyderm actually provides us with the solution to this. If I look at the, let's see, the build. What I'll see is that I can actually provide a tag for the Docker image that's being built for Selden. You can look at this script if you like, but what that's going to do is actually tag my Docker image that I'm building for serving with the Pachyderm job ID. And what this allows me to do is if I ever use this container for serving, it's tagged with that job ID. I can go back to Pachyderm and look up that job ID, see what model was used. And here in a second, I'll show you how to get all of that audit trail information. But basically, this links the world from Pachyderm to Docker Hub to Selden. Questions about that? How persistent is the job ID? Yeah, so all of your, let me go to actually, it's a good question. So the question was, how persistent are things, metadata things like the job ID and such? So let me answer that here. So this is this is a little bit more detailed architecture of the Pachyderm system. And you'll see that all of your version data is stored in this object store, like I mentioned. But then there is this persistent volume that Pachyderm uses for this version or metadata associated with the versioning, like job ID, commit IDs, repo name, et cetera. So all of that data is there in the persistent volume. If you tore down your Kubernetes cluster, that would be gone. But Pachyderm has basically similar to like a database, has an export and replay sort of functionality where if you want to tear down your cluster, you would just need to export that the state of your Pachyderm cluster, and then when you boot it back up, you just point it to that exported metadata plus the object store that you were using before, and then you're back up and running.
So that persistent volume, that has to be like local, or
It can be like, for example, he asked what the persistent volume would be. For example, in AWS, that might be like an EBS volume. Or locally, we're just, in this cluster, we're just using the disk on the node. But probably it would be something more like an EBS volume. Yeah. Other questions? OK. So this is running. Oops. I think. The build ran. Now the export is running. The reason why this is taking so long is that it's actually building this Docker image for serving and then exporting it. This would be something, again, that likely would run maybe in a CI/CD system. So that's going to be running for a few minutes. I don't want to bore you guys. So if I've already run this, a number of times prior. This should finish like before we're done, so I can show you. But I've already run this. If I can find the, there we go. So if I look on Docker Hub, these are previous versions that I uploaded. So like 2 days ago, I was playing around with this. I originally had the example 4 months ago. In each of these tags is a tag that corresponds to a Pachyderm job ID that was run in Pachyderm that built this model and exported it to Docker Hub. So while the current one is building, that'll take a few more minutes. Let's go ahead and get the inference servers up and running with one of these previous ones, just so we're not waiting around. You can go ahead and use one of these if you want, or you can wait till yours finishes and then use your image to launch the training. But how this will work is, let's go back to our Kubeflow app, Kubeflow Ksonnet app here. And remember, we deployed Seldon before. So I haven't talked much about Seldon yet. What Seldon gives us is some open source tools like the wrapper that we use to wrap our Python with Docker. So it gives us some nice functionality around that. It also has its own, you can specify a custom image that it will utilize for inference, similar to if you're familiar with like SageMaker. You can do a similar thing with SageMaker where you, AWS SageMaker, where you specify a custom image for inference. And then it will use that custom image, set up an endpoint for you to do inference. And you could spin up a bunch of those inference servers. So we've already deployed Seldon. All we need to do is generate those inference servers based on the image that we built in our pipeline, which is tagged to the Pachyderm job and all of the data and processing that we used in Pachyderm. So we can do that in this way here. So what you would want to do is take this. Actually, I already copied. So here, you can take this command and then just replace the Docker tag with one of these Docker tags that I've already built here on Pachyderm issue summarization, or you could wait for your image to finish building and upload to Docker Hub. But I'm going to take one of these existing ones and just go ahead and I'm going to generate a template for these inference servers, again with Ksonnet. And I'm going to utilize the pattern Seldon serve simple. I'm going to call it issue summarization model serving. And I'm going to use this image from that I already built. And I'm going to spin up 2 replicas to do this inference. So that's there. And now let me go back here. And then I just need to apply this to deploy those servers, which is the part that's been giving us trouble all day. Looks like it deployed successfully. And now, again, if I look at what's running in Kubeflow, oh, now, sorry for the wrapping. I'll go, there we go. I've got these 2 inference servers launching up in my Kubeflow namespace in Kubernetes. So I'll let those go ahead and create. Let me check on, remember, I've got my current build cooking in the oven. It's still running. What questions are there? The framework or the container? Oh, yeah, so sorry. If you want to use the one that I've already built previously, you could use, sorry, this is going to be like long and annoying, but you could use this, this tag. Oops, I didn't mean to run that. This tag, but you can find that here if you just go to Docker Hub, to the public repository Pachyderm /issue summarization. You can utilize one of these tags and copy it over. Other questions? Yeah. Yeah. Yeah, so the question is, what if I had several different models that are part of a project? How would I manage those? So likely how I would manage those, so in terms of Selden, what it will do is inference per model. So similar to like TensorFlow serving, you would have like a TensorFlow serving for a particular model. Here, so you might have a different Docker image for each different model that you have, but they could be namespaced somehow by project, right? My project _ model 1 : tag. My project _ model 2 : tag. And then here, I haven't really shown it, but you're not restricted to one pipeline in Pachyderm. So I could just as well go over here and say, oh, I'm going to start a new project, and now I'm going to create a repo, new raw data repo, right? And that's totally fine. Even though that repo is not connected to anything, I could build a whole nother pipeline off of that builds another Docker image for my other model. Does that answer your question? Okay, yeah. Let me know. Let that soak in, and then afterwards, let me know if you have more questions. Happy to talk through that. Yeah, back here. Yeah. So the question was, if I wanted to take the model and not use Selden, but just inject it into some other running process somewhere, how would I do that? I think that's a really relevant use case. So let's say I've already created like an API service that's using a current version of my model. I want to essentially just issue a request or something to that system to update the model or send the model somewhere else. What I would do is just come over here, and instead of like my export running this, whatever it's running, I could just say, curl blah, 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 and issue the request to send the model somewhere else to some other system, right? So remember that in each of these stages, you can run whatever you want, anything from a bash command to a Python script to a Scala binary to whatever. So if you wanted to, for example, just send data to a database on the export, you could just have a script that makes a database call to that thing. You would just need to create the secrets that you needed to connect to the various systems. Yeah, I think there was another question. Yeah. Yeah, that's what we're going to do here. Is it running yet? Let me see. Yeah, I'll have to see. Are there any other questions before we do that? Yeah.
It's still very complicated. Is it any way to visualize the whole thing?
Yeah, great question. So there is. So the question was, is there any way to visualize what's going on? Because here we're just working at the command line. The answer is yes. That's kind of where, the reason why I'm not showing it is because that's kind of what Pachyderm builds their business model off of. So Pachyderm has a whole enterprise version that also includes a pipeline visualizer and such. In fact, if you look at what's running here, you'll see that there's this dash running. And you can actually get a free trial for this. So if you go to your droplet IP, I think I'm using this one now, and then you go to 30080, port 30080, that'll pull up the dashboard. And that has a nice, might have to, depending on the Wi-Fi, let's see if there. So you can see in the background this visualization of my pipeline back here. And you can actually run your access controls and your advanced job statistics and visualize your pipeline and create pipelines with a GUI and everything there. It's just that's not part of the open source version, so I wanted to keep this tutorial part of that. Yeah. OK, so our inference servers are running. Let's go ahead and try to ping them. So what I need to do that is actually just set up a port forwarding. So you can run this command to do a port forwarding for those servers. Oops. Oh, again with the namespace thing. You guys have to keep me honest. OK. There. And then let's try to ping that from another terminal. So I'm just going to log in from another, oops. So you could just log in another terminal. Maybe grab that IP again, mine. And you could forward this, outside of the cloud as well, but now I just have this example curl. So here this is a long GitHub issue. So issue overview, add a new property to disable detection of image stream files. Those ended with -is.yaml from target directory, blah, 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 blah. So we want to summarize that. So we're going to curl that request via JSON to our inference server. And boom, we get out the very apt summarization, add support to the, which is not a bad summarization. Remember, we used a sample of the data, so probably we need to add more into our training data. This might be an indication of that. But you can see that we've gone from raw data through the pipeline of preprocessing, training the model, building the model, exporting it, and using the exported model in inference servers, and pinging the inference here. So that's the full pipeline. Hope you guys got that up and running. Just to kind of, in our last little bit together, I wanted to emphasize a few kind of cool features about this. First off, let's see if my build ever completed. OK, so you can see that my export completed. So actually, if I go back here to Docker Hub, I should see another tag here. That was 3 minutes ago it finished and uploaded this here. Now if you look at this job ID here, let's say I deployed those inference servers with this job ID, and now like my customers are complaining, hey, you did bad at summarizing my GitHub issues in some offensive way, I'm going to sue you. And now I need to go back and see, oh, well, what model did I use and what training data did I use and all of that to actually generate those inferences. Well, I can take that job ID and go over here and look. I can see that that will match here this particular build ID. And not only that, I can see that that build actually output this particular build commit ID into the version data store. So if I actually look at, what are the files in build for that particular commit ID, I can see that that includes a build directory, and in that build directory, I have these exact files. So I can go straight from that ID to understand exactly what was generated in my AI workflow to build that particular container. Now, all of that's nice, but we've only run things through once, which is not how things work in general. So to illustrate how this might be updated, one thing you could do is say, I'm going to go in to my split, and as was mentioned before, maybe I want to change the sample size. Okay? So I'm going to take it to 3,000 because my other model didn't work well. Okay? All I have to do now to update that, and this would be the same if you're, say, updating your model code, like maybe you updated your architecture and you're updating your model code, or you're updating parameters or hyperparameters, all of those sorts of things. You would just need to run an update pipeline command on that train. And by default, it won't reprocess that data, but I could go ahead and say, OK, with this new pipeline specification, I want you to go ahead and reprocess the data that you processed before. Oh, wait. Yeah, well, I'll illustrate it multiple times, I guess. Split. Thanks. And now if I look at these guys, I wasn't quite quick enough, but what happened was it went ahead and tore down the previous container and booted up a new one, scheduled a new one with the new, like if I change my Docker image, for example, if I change my code, or if I just change my, my config, it will boot up a new pipeline worker. And if I told it to reprocess, it will go ahead and kick off the jobs if I haven't lost my connection. Yeah. It's painful. You guys can try it locally. Hopefully that works here in a second. But it will have booted up those jobs that are running. Sorry about the connection issues. The other thing that I haven't talked about, so here we just did single node training. Kubeflow does include specifications, as we've talked about, for distributed training. And so if you wanted to utilize that, there's some examples out there for booting up distributed like TensorFlow jobs from Pachyderm. There's this custom resource definition in Kubeflow called TF job, and that will allow you to boot up distributed TensorFlow jobs very easily. Also, I couldn't spin up GPUs for all of you guys. Sorry about that. But in the Pachyderm pipeline specification, you can see that I can request a GPU resource. So if you had a whole pipeline, which is often the case where you have pre-processing stages that are on CPUs, and then a training stage, which is going to be on a GPU, and then post-processing and inference, which is on CPUs or whatever it is, you can just select and say, hey, this particular stage needs a GPU. And what will happen is that will be scheduled on a node with a GPU. but your pipeline will still operate as you intended. In other words, whenever its input data is updated, it will automatically trigger that job on the GPU, get the right data to the GPU node, do the processing, gather the right data off, and continue on to your other CPU nodes. So you no longer have to like manually be copying data in and out of GPU nodes. So that's a pretty nice thing. The other thing I haven't discussed, which I'm happy to afterwards with you guys, or now we have about 10 minutes left, is the distributed processing side of things. For example, if you wanted to do a batch inference for like a recommender system or something like that, you could spin up multiple, you can see here, there's a parallelism spec. I could actually spin up a whole bunch of workers that would process the same input repo in parallel, and I could split the data across those workers to do kind of like MapReduce-y style things for those sorts of settings. I don't know if I ever, looks like I'm having some sort of issues, but I got through most everything before the issues. Yeah.
Couldn't you have just built a self-contained Flask process there that picked up that H5 file?
Yeah, so the question was why, in this case, I could have like used Flask and not Docker to just pick up the serialized model. That's totally true. The reason why I use Docker in this case is because that's what Selden uses. You have to specify a custom image for it to use for inference, and so I needed to build that image. If you had your own custom like Flask-based API, you could just change that export stage to, instead of building a Docker image, just making the respective call to your API to get the model into that API.
So Selden just requires that.
Yep, exactly.
All right, thank you.
Yep. Yeah, great question. So the question was, how do you deal with errors if you have a failure in your pipeline? Let's see if I can connect again here. I don't know. My thing is, try this one. Nope, okay. So I'll just have to show you, but there's a pat control. So there's there's a few different answers to this. When a job fails, you might want to do various things. First of all, you might want to look at the logs corresponding to that job to see if you logged any issues. You might also want to see the data that was input to that and what it looked like. And thirdly, you might want to see like if there was some resource issue on your like memory or disk issue on your resources that caused an error. So in the first case, you would log similar to you would with any other Docker-based application. And what happens is you could get those logs either through Pachyderm, so there's a get logs API call. You could also get them from Kubernetes with their logs API, or you could get them through the dashboard, the Pachyderm dashboard. The data, you can see exactly what version of your data was input to that model, so you could examine that, and along with what Docker image was used and all of that sort of thing. If you're dealing with resource type issues like memory or disk space, it's really best to like pair this with another layer like that works well with Kubernetes, like Prometheus or something, where you're able to monitor the resource utilization across your nodes and even log like what pipeline workers are taking what resources on what nodes and that sort of thing. Other questions? Yeah. The what?
Database.
Oh, the database connection. Yeah, so the database connection would be similar to what we did with Docker. You would just create a secret in Kubernetes that contains the creds for your database, and then if you expose those creds to any pipeline worker, then you could just utilize them to connect to your database like you would in any other Python program.
But for the whole pipeline, everything seems to be versioning well, right?
Yeah.
But
So
at the end, for example, we want to collect the data into a database.
yeah, so in terms of ingress or egress to the database, if you just make the database call or the database query and process that in memory, then you've essentially lost the state of that query or the alterations that you're doing to your database. So oftentimes what we'll see people do is they'll have as their first stage of their pipeline like a query, and then they'll just dump the output of that query to the output of the stage so that they version control that query that's driving everything else. And then on the export, you might just dump whatever you're going to export to a repo, and then have a stage that just takes the dump and then updates the database accordingly. That way, you're actually version controlling what's going in and out. Yeah. Yeah.
So if I understood that correctly, you wouldn't be like sensing changes in the database, right, in the way that you would like a flat file. And so, is there some sort of scheduling, or like how do you control when the pipeline?
Yeah. The question was basically Pachyderm doesn't know about your database outside of like credentials that you would provide it or something like that. So if you want to like do like periodic queries of your database or something like that, there is a periodic scheduler built into Pachyderm, so you could actually just trigger a pipeline every day or every hour or whatever it is to do a query. The other thing you could do is have an external service, like if you want to make it more event-based, like when this happens, push a like a JSON trigger into Pachyderm, and that would trigger a call to a database and kick things off and that sort of thing. Yeah. Yeah.
So as a data pipeline tool, I'm curious to know, is it complementary to SageMaker or does it compete with SageMaker? Like, can you explain that?
Yeah, great question. So the question was, how would this relate to and or compete with or integrate with SageMaker? I would say that this is really complementary, if anything, but it's also like it's solving a different problem. So like SageMaker is very focused on training jobs and inference jobs and notebooks, right? And you can generate training jobs and inference jobs with their algorithms or with custom images. But if you want to have a 17-stage DAG that does all sorts of pre-processing and various things and manage all of the data input and output of every stage of those things, and potentially use arbitrary tooling for each of those things, whether that be R, Python, or whatever, Bash, that's going to be really tough to accomplish in SageMaker, at least in my understanding of what it is. But you could still integrate, like if you wanted to use SageMaker's inference servers, for example, with custom images, you could just take out Selden, like we did here, and just utilize their API for inference, supplying the custom images that we built in this pipeline. Yeah.
I wonder if you have some recommendations on the deploying and updating models in productions. So particularly if you already have the model in production, then we cannot just arbitrarily update those. Ideally, we should have some pipeline where maybe we can test the model on small portion of traffic and then redirect.
Yeah.
Yeah.
So the question was about updating production model pipelines in terms of filtering traffic over and also testing. So what we've generally seen is that people will have, again, you can have a whole bunch of different pipelines in Pachyderm, and you could even separate things out by namespace or even Kubernetes clusters. So you might have a pipeline that's your staging pipeline. Whenever your data scientist updates their code on staging, it will automatically update your pipelines in the staging pipeline, and it will run to success or failure. They could look at it and determine what's going on. When they're ready to cut it over to to dev, then they could cut it over on GitHub. That would trigger the updates to the dev pipeline. You could also integrate things like quality control and that sort of thing. Like I have that test data set. I could attach another pipeline to that test data set that would test my serialized model against the test data set and only pass it through to build and export if it passed a certain quality control threshold that I set or something like that. Yeah, so there's various models around that depending on what your needs are. But, yeah.
You might have a syntax error on your curl
Oh, maybe. Well, there's a PR opportunity if anybody wants a prize. I don't know if there's already been 2. So, yeah.
How does Pachyderm handle data parallelization for like very large files?
Yeah, great question. So I'll kind of end with this, and then we can take the rest of the questions afterwards. So Pachyderm's data parallelism is controlled in a couple of ways. So if I look, for example, at this file, you'll notice this glob here. The data parallelism, you need to figure out 2 different things. How many workers are going to process my data, and how am I going to split my data across those workers, right? So the glob here takes care of the latter. So with the / glob pattern, I'm saying always process everything together as one datum, and that's the only datum you can process. If I did /*, that would say, let's say I had 100 files under that repo, I would be saying you could process each of those in isolation as a separate datum. And so if you had multiple workers, if you had 10 workers, you could spread 1/10 of the files across each of those workers. Now to control the number of workers, I haven't included it here because we didn't utilize it, but there's a parallelism spec here, and you can actually set the number of workers to either something constant or a coefficient of the cluster size. So you could say, I want 10 workers, or I want, I want 3 workers if I have a 30-node cluster, something like that. And then if you pair that with Kubernetes auto-scaling functionality, as your load increases and your cluster would scale itself, then if you set things to a coefficient of the cluster size, then your pipeline workers would also scale along with that.
But it's still just one file.
No, it's really however you want to split up. So this glob pattern is just like a standard Linux glob pattern. So if you have like, for example, I think there's a example here. So if you have something like this, like you have multiple directories, like per state, if you do /*, that's going to distribute across each directory in parallel. You could even do like /California/*, and that would process each of those JSON files under California in parallel. Or you could do /*/*, that would actually distribute the processing over all the JSON files in isolation. So it's really flexible in terms of how you want to split it out. Yeah. Okay, that basically cuts us off, I think. So I think we should end things there. I don't want to keep those from lunch that need to go. Thank you guys for sticking around all day. I hope it was useful and you learned some things and got to get hands-on. Sorry about some connection issues. I'm going to stay here a little bit to answer more questions or join you guys for lunch. But thank you guys so much. Please come up. If you did submit a PR, I'll get you a prize. And thank you guys so much. It was a lot of fun.